Okay, worksheet 7.4, problems 4, 6, 7, 9, 13, 15, and 22. Starting with problem number 4, factor a 3 out of everything first. You can then use the minus b over 2a to find the x value of the vertex. So minus a negative 6 all over 2 times 1, which is 2. So 6 divided by 2 is 3. Plug a 3 into here to find the y value of the vertex. 3 squared is 9. 9 times 3 is 27. 3 times 18 is a negative 54 plus 24. And when you add all that together, you get a negative 3. So plug the x value of 3 in, you get a negative 3. So the graphing form is y equals x, change the sign, minus 3 squared minus 3. And then all of this converted into this, so don't forget about the 3 here, and that is your a value. So the 3 goes out in front. For number 6, again, use the minus b over 2a to find the x value. So minus a negative 8 all over 2 times 4, which is 8. Essentially, think of this as a plus 0. So there's a c value of 0. So negative 8 over 8 is a positive 1. Plug a 1 in here. 4 minus 8 is negative 4. The other thing we could do is we could have factored a 4 out of here, a 4x out of here, or just a 4, rather. Sorry. That's x squared minus 2. So we have a 4 out in front. So this stuff becomes here. Y equals x minus 1 squared minus 4. And we have the a value of 4 out in front. Oh, we got to have the descriptions here. So our vertex is at 3, negative 3. So right about here. It's upward facing. So it has 2 roots. And the 3 out in front makes it very narrow. Something like this. So this one here, 1, negative 4. We have a positive upward facing. So it has 2 roots. And if this one was narrow with a 3, then this one's even narrower, or we'll just say narrow though. So this one could be even steeper than that one. So the next one, right here. For this one, we need to determine the depth of the pool. What information do we need to know about the parabola? Well, if this is a model of a pool, it would be something like this, and the pool would be underground. So we're assuming that that the x-axis is the surface of the pool. So if we want to know the depth of the pool, we need to know the vertex. Okay? So problem number 8 says determine the depth of the pool. So determine the vertex. Minus b over 2a. So that's equal to minus a negative 2.8 all over 2 times 0.2. When you do all that math, you get x equals 7. From there, you can plug the 7 in to here, do all the math, and you will have the vertex 7, comma, negative something. That negative something will be the depth of the pool. Determine the width of the pool. What specific information will we need to know? The roots. So to find the roots, let's start with this one here and work that one down here. I would factor out a 0.2. So y equals 0.2 times. Actually, a 0.2x, I'm sorry. 0.2x, you're left with x, and then when you divide 0.2 into 2.8, you get a 14. Oh, that came out nice and evenly. So from there you can figure out what the roots are, and then you can determine the width of the pool. On the back, problem number 13. This one here, the vertex is at negative 6, comma 1. So we have negative 6, comma 1. It has a downward facing, so it looks something like this. That's for this equation right here. That's the approximate graph. For this one right here, we have a negative 6, comma positive 1. So again, negative 6, comma positive 1, but this one is upward facing. Of course, these are a little bit narrow because they both have a 2 in front of them. So their vertices are both maximums? No, this one is not a maximum. The graphs have the same shape but different vertices. This shape and this shape, well, they both have the factor of 2, so they would be the same shape, but different vertices. This one's at negative 6, 1. This one's at negative 6, 1. So the vertices are the same, so this answer is also incorrect. One vertex is a maximum. Right here, this is at the maximum. The other is a minimum. Right here, this is at a minimum, so that is answer D. So it helps if you do an approximate sketch of each graph. For problem number 15, your vertex is at negative 2, positive 3. So we go to negative 2, positive 3, and we plot the vertex. It's a negative, so it's going to go something like this. So it has 2 roots. You would do something similar for these ones here. For number 22, find the x-intercepts of the graph. I would recommend for number 22 that you would do the diamond. If you see the pattern on this one, it's a specific formula for this one, but if you don't see that right away, we can go with the diamond. 1 times 9 is 9, negative 6 goes underneath, so we have a negative 3 and a negative 3. You can either split the middle term, which is 9x squared minus 3x plus 1. So you factor by grouping. Out of this one, you can take a 3x out of both of them, a 3x minus 1, and here you take out a negative 1, so it becomes a 3x minus 1. These two become 1, and the bridesmaids and groomsmaids get together. So it's 3x minus 1 times 3x minus 1. So this is 3x minus 1 squared, and you would set that equal to 0. The other way to do this is 9x minus 3 and 9x minus 3. You divide this one by 3, we get 3x minus 1. We divide this one by 3, we get 3x minus 1. So they're both 3x minus 1 squared. We have to set this one equal to 0. So 3x minus 1 equals 0. Add 1 to both sides. 3x equals 1. So divide by 3, so x is 1/3. So the root, or the x-intercept, is actually at 1/3, comma 0. This is the final answer to the question.